Hello everyone. Welcome back to PamTen's YouTube channel. And in today's session, we'll learn about binary search and implement some fundamental problems using binary search. So I am using this platform called as TUF Plus, which is primarily for data structures and algorithms. And today we'll specifically focus on binary search. So this is the problem statement for binary search. So we have a sorted array. So for binary search, you'd have to keep in mind that the array has to be sorted. If the array is not sorted, you cannot apply binary search. So now that you have a sorted array, you will be given a target integer and you would have to return the index where this target integer is present. So here, this target integer is present at 0, 1, 2, 3, and 4, index number 4. This target integer is not present in this array. That is why you are returning -1. This target integer is present at the 0th index, so you will return 0. Now this is how binary search works. So what you do is you find out the middle value in this array and you take the left side and the right side. So here 0, 1, 2, 3, 4, 5, 6. So 6 by 2 will be 3. So you'll take the index 3, 0, 1, 2, 3. So this will be your mid value. Now you'd have to check if 9 is greater than what is present in the middle. So is 9 greater than 5? Yes. So since 9 is greater than 5, this would mean that you can eliminate the entire first half. So since this is greater, this will not be present in the left half. So you can eliminate this entire part and come here. And now in this, what you'll do is you'll again segregate this. You'll again find the middle of this. So here middle will be this. Now since this is middle, the target value is exactly equal to the middle value and you can return this. So what you're essentially doing in binary search is find the middle, check if the target value is greater than or lower than the middle value. If the target value is greater than the middle value, you eliminate the left side, go to the right side. If the target value is less than the middle value, you eliminate the right side and go to the left side. And now, what we'll do is we'll go ahead and write the code for this. So I will have two pointers over here. I'll have low and I'll set that to be index number 0. And I'll have high and I'll set this to the last index over here. So low is pointing over here, high is pointing over here. So high is length of nums -1. So now that we have this, I will have a loop and here in this loop, I'll basically check while low is less than or equal to high. So till both of them become equal or till low crosses high, till then this loop will continue on. So in this, I will calculate the mid value. So mid would be equal to low plus high minus low by 2. So this basically becomes 2 times of low plus high minus low, which is equal to high plus low by 2. So we have the mid value over here. Now that we have the mid value, I can go ahead and find the conditions. So if nums of mid is double equal to the target value. So I have found out the middle value and I want to check if this is equal to the target value. If it is actually equal to the target value, I can just go ahead and return the index. Now, if that is not the case, elif, I would want to check if target is greater than nums of mid. So is target greater than this? Yes. So if that is the case, I would want to take the low value and set it to be after this. So initially low was here, high was here, mid was here. So what I'll do is I'll take this low value and I'll point it to the index after mid. So low is equal to mid plus 1. Now my window becomes this 9, 1. So window basically becomes 9 and 12. Now that the window is this, what I can do is, so again, I would have to check the final condition. So if mid is directly equal to target, I return the mid. If target is greater than mid, I go to the right side Else, if target is actually less than the middle value, then I can eliminate the right half, which would mean high is equal to mid minus 1. And finally, you will have your solution stored in mid. Now, if there exists a condition where this value is not present in the array, you can just go ahead and return minus 1. Let's run this and see if we are able to pass the test cases. You see, these are the two base cases which have been successfully passed. Let's also submit this and see if this is accepted. You see, we have successfully passed all of the test cases in here. So this is binary search. Now we'll also look at a simple problem on binary search. So this is called as lower bound. So in this problem, you are again given a sorted array. So if you are given a sorted array, the first thought which needs to come to your mind is this can be solved using binary search. Now we're supposed to find out the lower bound. So what exactly is lower bound? Lower bound helps to find the first or the smallest index in the sorted array where the value at that index is equal to or greater than the given key. Okay, so the smallest index where it is greater than or equal to the given key. So the key is 2. Now, this is the index. This is the smallest index where it is greater than 2 or equal to 2, right? So this is equal to 2, this is equal to 2, but which of these is smaller? This one. Similarly, which is the index which is equal to or greater than this? So this. So 0, 1, 2, 3. Index number 3 is where you'll find a value which is greater than this. So this is the lower bound. Let's go ahead and implement this. Again, it will follow the same approach. So we'll have one pointer pointing on the left side. Then I'll have high. I'll set this to the last index over here. And I'll have a loop while low is less than or equal to high. What do I need to do? I would need to take the middle value. So if mid is equal to low plus high minus low by 2, I have found out the middle value. Now, I would want to see if this middle value is greater than or equal to this target value. So, if nums of mid is greater than or equal to target value, I'll have another variable here called as ANS. Initially, I'll set the value to be 0 in this. So if nums of mid is greater than or equal to target, what do I need to do? I can just go ahead and store the middle value in this. So here initially 0, 1, 2, 3, 3 by 2 is 1. So 0 and 1, right? So middle is this. So is this particular value greater than or equal to 2? Yes. So what I'll do is I'll go ahead and store this index in this. And now since this is actually greater than target, now there is a possibility that this value could also be present on the left hand side. So I'll say high is equal to mid minus 1. Now if this is not the case, that is if target is actually greater than nums of mid, then I can just say low is equal to mid plus 1. And finally, our answer will be stored in ANS, and that is what we shall be returning. Return of ANS. Let me run this and let's see what we get. We actually have a runtime error over here. So we don't have target. This is actually X. Let's change this to X over here. Now let's run this. And you see that we have passed the two test cases. Let's also submit this and let's see if all of the test cases are accepted. Seems like some of the test cases are incorrect over here. So let's see what else can be modified in this. So low is this, high is this, answer is this. If nums of mid is greater than or equal to X, we store this in answer. So this actually has to be length of nums. So if no such index is found, return the size of the array. So that is what we need to return over here. And here, this is how we're calculating mid. Okay, high is mid minus 1, else low is mid plus 1, and we're returning this. Now let's submit and let's see what is the result we get. So seems like we have passed all of the test cases. So these were some fundamentals of binary search and how you could do problem solving with it. Thank you. And if you've liked this video, do like this video and also subscribe to our channel. Thank you. I'll meet you in the next one.